Inverse functions and their representations. I have got relation K, notice my x values and my y values, and relation K inverse. Notice my x values and my y values. Now if you compare these two, hopefully you should see that what has happened from relation K to relation K inverse is that the x and y coordinate values were interchanged. And that's all that happened. So if I have that situation, interchanging the first and second coordinates of each ordered pair in a relation produces what's called the inverse relation, indicated with that little -1. It sort of looks like an exponent, but it's not an exponent in this situation. It's just a symbol indicating inverse relation. Okay? Now, interchanging the first and second coordinates is going to be very important with this. It's going to pop up a lot of different times while we're just in this video. So my relation K, my domain here, became the range here. The range in K became the domain in K inverse because of this interchanging. Now I ask you to graph relation K and K inverse to see if they look like straight lines. Now you can do this on paper. It's just easier for me to do it on the calculator. So I went to my stat, to my edit, like we've done before, and I put these points in, but I put them in a little bit different than what you might have seen. L1, L2 is my relation K. L2, L3 is my relation K inverse. And I asked the calculator to graph this. When I do that, zoom 9. So this one right here is my relation K, and this is K inverse. Okay? Now this point right here, the window, here I'll check my window. The x-axis, notice it's going by 2's, as is my y-axis. So if I get back to my graph, this is -2, 2. This would be -1, 4. But now this one would be 2, -2. So you see this point right here, that's the me interchanging those two values. These two coincide, as do this one, as do this one. Now my picture right now, the x-axis is a whole lot longer than the other one. Let me see if I can do a zoom square on this one, because I need you to see something. If I put a line in here, y equals x, I can do that real quick. This point, its distance from that line is the same distance as this one. And that's another property that we'll be looking at in just a bit. I'm going to leave that picture because we'll be back in a bit. So do they look like they're on straight lines? I'm going to go, yes they do. Find the equation for relation K. Well guys, we've used the stat before. So let me go to stat, over to calc for number 4. I'm going to tell it that I need L1 and L2. Remember, I've got 3 different lists. So I just, we've done linear regression. So second L1, comma, second L2. And there's my equation. Do you remember that a correlation coefficient of 1 is a perfect fit? So my equation here that I'm about to move, it's my k function is equal to 2x plus 6. So k of x equals 2x plus 6. My inverse, well, let me do the same thing. Stat, over to calc, number 4. But now those were in L2 and L3. So that equation, my k inverse equation, would be 0.5x minus 3. There. And if we graph those, let me go graph those real quick. Yeah, I want to keep you there. So 2x plus 6, and 0.5x minus 3. And let's go graph. Oh, that's so cool. And goes right through because it was a perfect fit. Alright, if a relation is defined by an equation, interchanging the variables and then solving for y produces an equation of the inverse relation. The following is an example of this procedure. Now, up here we were given points. What they're saying here is, well, what if they don't give us points, they just give us an equation? Well, now if you'll notice, that should look familiar, that 2x plus 6. Let's see. Step 1, substitute y for f of x. If it's in functional notation, you need to see x and y. So now I'm going to interchange. So I'm going to put x here and y here. Solve for y. Boy, you've done this a whole bunch of times. So I'm going to subtract 6. So let me subtract 6. Divide everything by 2. And then you can rewrite it if you want. If you want y equals 1/2 x minus 3. Now you're almost done. But now if the question was to find the inverse, you've got to use that notation. So substitute the inverse, that f inverse notation, in for where y is, and you've got it. Now if you'll notice, this was my original, right here, my k of x. Notice my k inverse of x. There it is. So I can find it if I'm given points, or I can find it if I've got an equation. It's not that bad, just some steps. Horizontal line test. If it is possible for a horizontal line to intersect the graph of a function at only one point, then the function is one-to-one and its inverse is a function. So, with this linear equation, if I used a horizontal line test, all that means is I can, interchange my x and y value, and I would get another, different equation, but it would be a function. But think about a parabola. Remember a parabola? If I had a parabola and I used the horizontal line test, that would mean that I could possibly have two different points with the same x value. So that's why we use that horizontal line test. So if it's possible for a horizontal line to intersect your graph of a function at only one point, then the function is one-to-one and its inverse is a function. Consider if a function either increases or decreases on its entire domain, then it is one-to-one. Now there are some problems normally that they will modify or restrict the domain so that you will have a function. So that's just something to consider, to think about. Probably look at the homework and you'll see. So important facts about inverses. If f is one-to-one, then f inverse exists. The domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. Remember what I said a little bit earlier about interchanging the first and second coordinates? That's where they're coming with number 2. Number 3, if the point AB lies on the graph of f, then the point BA lies on the graph of f inverse. Almost says the exact same thing as 2. Interchanging your first and second coordinates. To find the rule for f inverse, or the equation, replace f of x with y, step 1. Interchange x and y, step 2. Solve for y, that's step 3. And the last thing you do is substitute that f inverse for y to show somebody that you're finding f inverse. And this part 4 here, or line 4, is what we did earlier, right here in the middle. The graphs of f and f inverse are reflections of each other across the line y equals x, which is what I've got right here. Because if you would turn your calculator sideways, I can't, but if you turn yours sideways, you'll be able to see that what you have here is a reflection going across. Okay? And that's it for this one. Thank you.